Stanford University.
All right, everyone, welcome to yet another episode of CS 193P. I'd like to welcome a couple special guests today. We've got some folks from Wired sitting in on the class today. They may have spoken to you already before class, or if they haven't, maybe that'll happen after class. Also, if I seem nervous today, it's not because of the Wired guys, no offense. My mom is sitting in the class, which reminds me of the time freshman year when my mom came down to Stanford to go to some classes with me. And we walked into 9 o'clock IHUM section, or IHUM lecture, sorry, in Kresge. And we walk into the lecture hall and we sit down, and my friend Ellie from my freshman dorm looks up and sees me and just has this utter look of shock on her face and says, "Evan, what are you doing here? You never come to this class." So hopefully you guys can avoid busting me for anything I may have done up until this point. A couple of quick announcements. First of all, assignment 3 is due tomorrow at 11:59, the usual routine. So if we have any questions about that, we can answer them now or during the lecture as they occur to you. Anything that immediately comes to mind? Not really? We're cool with all that? Oh, yeah. Okay, so the question was, she's having some trouble getting user defaults to work. Maybe were you using NS user defaults, shared user defaults? Oh, the syntax of it. Yeah, maybe if you can send us a code snippet on the course email list, we can get it hashed out there. We'll actually be doing a little bit of that in a demo today, so maybe that'll answer your question. Anything else? Yeah. And so Presence 1, the assignment is going to be posted on the website this evening, and that'll be due next week on Tuesday. From here on out, all assignments will be due on Tuesdays at midnight. 11:59. So there was that one sort of hiccup where we had one due on Thursday and one due on Tuesday because of the compressed nature of the spring quarter. And then this Friday, the usual optional interesting topics section. The topic is going to be preparing apps for the App Store. So this is, if you're planning on uploading your Twitter client to the App Store after the quarter's over and making $1 bajillion, this would be a good one to attend. We're not sure whether it's going to be run by one of the App Store folks or by our own illustrious Paul Marcos, our behind-the-scenes lecturer, but we should have some more info on that once we get a little bit closer to Friday. And that's in the usual location, building 200, 205. Any other questions about this, about the logistical stuff? We're good? A couple of other announcements. There are some online resources for those of you out there in TV land who are auditing the course. We wanted to get these links out there because they seem to be becoming a good place to get questions asked and answered. You can see the links, groups.google.com/group/iPhone AppDev auditors, and also cs193p.com. I don't know why I didn't think to register that before the course started. The folks running these seem like really, really nice people. They're not affiliated with Stanford or with Apple, so keep that in mind. If I don't know, they tell you to give your credit card number to them or something, probably shouldn't do it. And then also don't forget devforums.apple.com is also a great place to discuss anything related to Cocoa Touch and iPhone development. Along these same lines, we've gotten a lot of requests from all the folks out there for assignment solutions for the assignments that have already been completed. The short answer to this is that we're lazy. The longer, sort of more nuanced answer is that we tend to reuse some course materials from quarter to quarter, from year to year. It would be kind of a bummer for us to have to reinvent a whole new slew of assignments every time we teach this course or the desktop Mac programming course. There are common elements that we tend to reuse. So that's why we tend to not post sort of definitive, like here is how you solve this assignment type stuff. If you'd like to discuss your work on the assignments, especially if you're auditing and you just want to get some feedback to know if you're doing things the right way because you're not getting graded, that would be fine to do on either of those two sort of external sites. If you're a Stanford student, obviously, if you choose to use those resources, the honor code is in effect. You need to include a note with your submission saying, this is where I received help and how much help I received, kind of the usual drill. And we would also request that you don't, whether you're enrolled or auditing or whatever, to not distribute completed assignments, because that's sort of, that's kind of what we're looking to avoid. Any questions about that? I'm assuming most of the folks here are probably enrolled, so yeah, I think that's all we've got in terms of announcements. So today's topics, we're gonna start by taking a little step back and kind of looking at how iPhone apps tend to be organized and designed and put together, and what some of the differences are between iPhone apps and desktop apps, and how that influences your design. We're then going to talk a little bit more about model view controller. Al mentioned it in last lecture, and I wanted to speak to some of the nitty-gritty, like why do we use model view controller, and what are some of the specifics when it comes to communication and relationships in MVC, because that's really the meat of it. And then we're going to talk about view controllers, which are a big part of building iPhone applications. Finally, we'll take a little look at the first presence assignment. So if there aren't any other questions, let's get into it with designing iPhone applications. Let's start by taking a look at Mail as it exists on both the Mac OS X desktop and on the iPhone. And it's clear, I mean, obviously these two apps, they share a lot of DNA. They're trying to get the same thing done for the user, but in terms of how they're actually put together and presented on the screen, there are a lot of big differences. If you look at the Mac app, and actually almost any desktop app, no matter what it does, what platform it's on, you'll notice lots of different types of content in one window. In that main window underneath, you've got a list of mailboxes, you've got lists of email messages, you've got an individual message, and then you've got a separate window on top. The user can toggle between these two windows at will. They can work on the message. There's a lot of stuff going on. And that's great, especially when you have lots of screen real estate. The iPhone is kind of a different creature. You've got 320 by 480 pixels. And it's I wouldn't say that it's lobotomized or anything, but it's definitely presented differently to the user. So let's start to think a little bit more about what the differences are and why those differences exist. If you look at maybe a first attempt at an iPhone application where someone has attempted to put the bulk of their application all on one screen, it gets kind of scary because there's not a lot of space. You've got maybe lots of different types of data all being displayed. It's kind of overwhelming, and it doesn't really aesthetically look too pretty. So as we saw in Mail, an alternative approach, and there's still a fair bit of stuff going on the screen here. But it's showing one type of content. In this case, it's a single email message. There's some tools down at the bottom of the screen that allow you to interact with that message. But we're not trying to show you both a list and a single message, or the message as well as all the inline attachments. Try to keep it relatively simple. Another great example of this is the Photos app. You go in here, and once you drill into an album, all you're looking at really are the photos from that album. You're not looking at anything else. And we actually try to fill the screen up with your photos, to the point where we're actually drawing underneath the status bar and underneath the toolbar at the bottom, all that stuff. So some sort of guiding tenets, these aren't rules, but some suggestions to keep in mind when it comes to how you're organizing content and how your app fits together. First of all, focus on your users' data. Whether they're using address book or photos or Safari or some Twitter client or whatever it is, they've got some data that they've invested in this application most likely. And it behooves you to really try and fill the screen up with their data and avoid kind of unnecessary adornments and little widgets. And the more you can fill the screen up with your users' data, the more it's going to feel like theirs, like it belongs to them. Another thing to keep in mind is just try to show one thing at a time, one type of data. This isn't a hard and fast rule, but it can be helpful when you're trying to figure out how to simplify. One sort of phrase that we sometimes repeat is this idea of a screen full of content, and thinking of an application as, rather than just it's an application that does all this stuff, think of it as many individual screens full, whatever, of content that are sort of chained together. Each of these screens has a job, has a very specific job, and knows how to do things related to that purpose. And it's linked together with other screenfuls of content. And that allows you to build an app that's pretty complex, but is also non-intimidating. Does that make sense? So there are a couple of patterns for organizing an application that's made up of many screens full of content. You've seen these on the iPhone. These patterns are used over and over again. The first one is the use of a navigation bar up at the top of the screen. The second one is the tab bar down at the bottom. These are in many apps all over the place. Almost every app has a navigation bar. Let's take a little closer look at what these things actually do and what they provide, and what their impact is on an application. In a navigation bar-based app, you've got this bar at the top of the screen that provides some context about where the user is, where they've been, what's going to happen when they go back, and also for example, the plus button up here. The most frequently used commands in the application are often good to put in the navigation bar, because that's one of the first places where users will look for buttons and all that sort of stuff. So it's a great place to sort of, that's sort of the user's starting point when they're assessing where they are and what they can do from this point in your application. Navigation bar presents a hierarchy of content, parent-child relationships. And the user can drill down into greater detail by selecting something or maybe typing some text. But it could be a tree. It could just be a simple ABC parent-child type relationship. This is how you can present something like an address book, which has a lot of different levels without being too intimidating. The second pattern, as we mentioned, is a tab bar-based app. So it's got several parallel modes. These modes exist in isolation from one another, usually. Clock is a great example of this. You've got the world clock, the alarm, the stopwatch, almost like mini apps. They're sort of related, though, so they're tied together under this single umbrella using a tab bar. And as you may have noticed, actually, if I step back, some of these modes actually have a tab bar or a navigation bar at the top of the screen. So it's possible, and iPod and the store apps are a great example of this, of combining both a tab bar metaphor, sort of the top level modes you switch between, and then some of those modes may have their own navigation hierarchy up at the top of the screen. So we'll talk a little bit more as the quarter goes on about how you would combine these things. But that's sort of the lay of the land in terms of the two most common types of ways of organizing content in an iPhone app. You're certainly welcome to come up with some other metaphor, some other way of doing it. The advantage of using navigation bars and tab bars is that your user already knows how to use them. They've been seeing them all over the place in almost every app on the phone. It's an immediately familiar sort of representation on the screen. So thinking more about the sort of screenful of content idea that we mentioned before, think of these screenfuls as slices of your application. So you've got a hunk of related application logic, some views, some data, some behavior that's associated with button presses and what happens when you type in that search field and what happens when you select an item in the list. It's all sort of packaged together as a self-contained unit. And this sort of takes us back to what we discussed in the previous lecture about model view controller. In this case, if we take a step back, looking at the address book view here, there's obviously some data under the hood, the representation of this particular list of people. We've also got some views, right? The table view, the custom table view cells, if there's any custom drawing going on there, all that sort of stuff. And then it's glued together by the brains of your application. And presumably there's some object somewhere that knows what should happen when various user actions are performed. So we've got our model, our address book data over here on the left side. We've got our view. In this case, it's the table view. Table views are all over the place in iPhone apps. They're very, they're ubiquitous. They're very easy to use as is without doing a whole lot, writing a ton of code. We're going to talk about those next Monday. And then these things are sort of tied together. The relationships are mediated by this controller. Like I said, the brains of your application. And if we think about this a little bit more generically, model view controller. This is the mantra that we'll be chanting, beating on a drum as the quarter goes on, model view controller. It's important, actually, before we continue going down the path of actually building an iPhone app, I wanted to talk a little bit more about model view controller and some of the reasoning behind it. So model view controller, first of all, why, and then second, how. So one reason why model view controller is useful is, have any of you ever used the word spaghetti, spaghetti code to describe some code that was just really, there were a lot of dependencies and you couldn't quite unravel it. You were probably describing somebody else's code, I'm sure, because I've never written spaghetti code. But one advantage of model view controller is that it suggests clear responsibilities that make your code easier to maintain. So rather than having a single monster class that is dealing with the database and it's also doing a bunch of drawing on screen and it's tying all these things together, you can sort of segment these things up into sort of well-defined areas of responsibility. So as much as we may like the flying spaghetti monster, that shouldn't be, those words hopefully should not be used to describe any code that you write. Another reason why a model view controller is helpful is that separating your responsibilities in this way leads to reusability. And reusability, when we're doing these kind of simple demo apps here where we're drawing a little view on the screen and bouncing it around, whatever, great if I can reuse this little red square class. But every application eventually becomes more complex than you would expect. And you always, down the road, you're like, well, I want to add this feature, but I'm going to have to copy all this code and figure out how to unravel it from where I was using it before and use it in this new place. So one thing that model view controller helps with is to eliminate dependencies, sort of define clear responsibilities and ways of communicating that improve the reusability of the code that you write. And this in turn leads to one of the holy grails, in my opinion, of software engineering, which is avoiding writing code. It might sound kind of funny, if your job is to dig holes for a living, you probably aren't really psyched to hear about ways to well, maybe you are actually. You want to dig less holes, but doing less work means writing less bugs, means maintaining less code down the road. So reusability, it's great. So those two things in mind, reusability and maintainability, those are whatever. Think what you want about them. If you've decided to adopt MVC, there are some ways of communicating and relating these objects that may help you to achieve both of those goals. So the questions that we want to ask are, how should these objects communicate? And which objects know about one another? This was a question we sort of got after the last lecture. Should the model object know about the view object? Should the view object know about the model object? There aren't hard and fast rules here, but there are definitely some guidelines that we can suggest. Yeah, Greg?
This came up in some
That's a good question.
just a little confused by
Yeah, the question was, the question was in the Polygon, in the Hello Poly app that we've been working on in assignments 2 and 3. The question was, is it a violation of MVC for the view to know about the model? And I would argue, in my opinion, it's not. As long as it's a sort of well-defined and reasonable amount of knowledge about one another. So I mean, if you've got this Polygon model object and a Polygon view class, it probably makes sense for the Polygon view to know about the Polygon to some degree, at least maybe not in the in terms of the guts of the Polygon, but it's not the worst thing in the world for some knowledge to be going on there. The thing that you definitely want to avoid is having the Polygon model object know anything about the Polygon view. Because that really, and we're going to talk about this in a little bit more detail. Actually, here we go. So the Polygon class is our model object. Typically, it should not be aware of the views or the controllers. This is typically the most reusable bit of code that you're going to write. As we noticed, we initially wrote this Polygon class as part of a command line tool that was just printing out text in the user's console. And then we were able to take that class, maybe change a pound import at the top of the file, but use it in a totally different context and not rewrite a bunch of code in it. So these are typically the most reusable bits of code. The question that you're led to from here is how does this object communicate with other objects, right? Because let's say somebody has a Polygon object and they say set color, set the color to red. Obviously, there may be some interested objects which care about that, which want to know. Maybe a Polygon view wants to redraw once this Polygon model object has a value changed. So there are a couple, there are many ways to do this. A couple of the most common ones are two mechanisms. One is called key value observing. If you've done programming in Java or some other languages, you may be familiar with the concept of listeners, where some object registers its interest in another object, maybe for a subset of that object's properties. So perhaps we could create some mechanism with this polygon object where some other interested object, like a polygon view, can say, hey, I've got a reference to you. I'm interested in hearing about changes when the number of sides and the color changes. And when that happens, that change will be broadcast to the view without the model object really knowing too much about who its listeners are. Does that make sense? So it's able to communicate those changes in a sort of generic way where there isn't too much knowledge on the model side. Notifications in Cocoa in the Foundation framework are another even more generic way of doing this. With notifications, the interested object doesn't even need to have a specific instance of, say, the Polygon model class in order to register its interest. It talks to a notification center, which is this even more, it's this object kind of floating out in space that keeps track of people who are interested in different notifications. A notification can just be a string, basically. So you might say, I'm interested in the Polygon sides changed notification anytime anyone broadcasts one. So obviously, it's a bit more of a blunt tool. Key value observing is more of a sort of precise, I'm interested in this object kind of tool. But these are a couple of ways that you can propagate interesting changes from your model to the other parts of your app. Is there a question? Yeah. So the question was, are notifications a built-in tool, or are they something that you're going to implement yourself? So there are classes for notifications in the Foundation framework, which is part of Cocoa Touch. The main one that you would want to look at is NS Notification Center. And that provides the means for both broadcasting and listening to notifications. In terms of actually getting the notifications for when a Polygon side change happens, that's up to you. So you've got to publish the name of the notification. Again, it's a string usually. You're going to have to broadcast that notification in the appropriate places in your app, and you'll have to listen to it in other places. So the infrastructure is there, but it's up to you to use it.
Anytime there are.
Right. So the question was with respect to key value observing, is it already set up for you, or is it something that you need to sort of, is it something that you just opt into, or is it something you need to kind of roll yourself? There are some, I believe is it a category or a protocol, or there are mechanisms built in to NSObject for observing and broadcasting key value changes. It's up to you to observe those things, and in some cases it's up to you to broadcast them. But there are a lot of cases where it can actually happen automatically. It's a little bit more complicated than we're going to go into in this lecture. But if you shoot an email to the class list, we can. There's some documentations we can point you toward that can flesh it out a bit. It's not something that you need to do for any time in the foreseeable future, but it is a good thing to investigate. Any other questions? All right. So this is the model side of things. We're going to take a look at the other two legs of the tripod, the view side of things. So our example here is a Polygon view class, which we've written. Perhaps it's aware of the Polygon object. Maybe it's not. Maybe we've abstracted it. The benefit of avoiding that knowledge is sometimes it's worth it, sometimes it's not. But I would certainly not. I wouldn't be cringing or freaking out if my Polygon view knew about my Polygon object. But you definitely don't want your view objects to be aware in a very concrete way about your controllers. So views ultimately tend to be pretty reusable as well. If you think about, especially the very generic view classes in UIKit, UI button, UI table view, UI slider, those things you can pretty much drop in and hook them into your application without changing a lot about the button or the slider itself. And again, there are some indirect ways of communicating changes which allow you to maintain these separations while also enabling useful behavior. One that we've done several times now is target action, right? So for a given view class, maybe there's something interesting that happens to that view, and that view wants to do something when that action happens, whether it's a slider getting slid or a button getting pressed. And by using target action, you can specify some object and some method to invoke on that object when an interesting event occurs, like a button press. Another way of communicating with the controller is something called delegation. We've spoken a little bit about delegation, mostly in the context of UI application. But one of the best examples of delegation that, again, we're going to be talking about on Monday is UI table view. UI table view actually has two objects they sort of fall under the delegation umbrella. There's a delegate, and there's also a data source. And these are objects which are separate from the table view, which, when interesting things happen with the table view, like a row getting selected, or the user scrolling to reveal more rows, and the table view is trying to figure out what to display. These are ways to hook up your view object with the brains of your app in your controller. So when you're thinking about view communication, don't write a polygon view that knows about the polygon controller and has this sort of hard dependency. Kind of separate them out and think about using things like target action and delegation. Yeah. So the question is target action a special case of delegation? I guess if you think about it in that way, I mean, they're definitely cousins or something. I mean, you're specifying some object. I mean, in this case, there's typically a single method or a single event happening, and you're saying, when this thing happens, tell this object and send this message to it. Delegation tends to include a slew of methods. For UI table view, for example, if you're set up as the delegate, there are a bunch of methods that will be maybe invoked on you. Maybe one sort of distinction is that typically target action is you want to hook it up to some code that's going to execute when this event occurs. And delegation sometimes implies asking for permission. Like sometimes you might have an object or a delegate method which is like, should I, what's a good example of that? Should. Yeah, so an example from macOS 10 is that when you click on the close button on a window, the Windows delegate will be messaged, and the window will ask its delegate, hey, should I close right now? And if it wants to close, it can return yes. If it doesn't want the window to close, it can return no, and then pop up a little alert sheet or something. So it's sort of implied that with delegation, sometimes you're changing the course of events in the application. Maybe that's the way of summing it up. Yeah.
So for the Hello Poly app, it would be preferable not to have a pointer in the view class object pointing to the controller?
I would say so. I mean, obviously, Hello Poly, it's a simple app. Yeah, sure, exactly. I mean, for any trivial example, you can pretty much hook things up and get them to work, and you're like, okay, I'm ready to ship it. If you envisioned, doing any more work on this thing, I would definitely recommend trying to keep those things separate.
So you'd recommend using one of these two?
Yeah, probably. So for something like, the polygon got clicked or something like that, you could have a generic means of communicating that. Obviously, I mean, these things aren't enforced at the language level. It's not like there's anyone who's going to necessarily slap your hand if you don't do things this way. These are sort of best practices. They're design patterns for saving yourself some grief in the future, if that makes sense. And we will, as we're grading your assignments, especially as we start writing the Twitter client, if we notice, cases where you're maybe not following these conventions, we'll mention it to you. Certainly in the first couple of assignments, we're not going to downgrade you to a check minus if you accidentally violated some rule of MVC separation. Maybe in, at the very end of the class, if you're still hammering your head against the wall, we might, I don't know, something. But I mean, it's not going to be something that keeps your app from working, but it's going to be something that maybe hurts you down the road. Does that make sense? Any other questions about this stuff? So the third leg, obviously, is the controller object. So the controller, typically, it's running the show. It's getting these view objects and getting these model objects and wrangling them together and connecting them into a way that, in a way that allows it to be useful to the user. It's the brains of the operation. It manages the relationships. It's the one who decides when the button is pressed. Should I, slide the user to a new screen or pop up an alert dialog or crash and quit the app or whatever. So typically the controller, and there are exceptions to this, but typically the controller is app specific. So it's not terribly reusable. And honestly, if you were to attempt to write a lot of controller code that was super reusable, you'd probably be creating more work for yourself than is worth it. So it's okay for these things to sort of live in one application and not anyplace else. So those are sort of the three, the model view controller. These are sort of how we're going to encourage you to have them communicate with one another and how their responsibilities should be separated out. So communication MVC, obviously the controller, it's got a pointer to the model, it's got a pointer to the view, and as we mentioned, there are cases, this is maybe a bit more of a gray area. I'm certainly fine with it. The view knowing something about the model object, especially if they're tightly coupled, like a polygon view and a polygon object. If it was a table view, the table views are pretty generic. So like a table view should probably not know anything about polygons, right? Or anything about the specifics of the data that it's displaying. That's where the controller comes in handy. So there are different types of view objects. Then the view can communicate, wow, that's really dark, but there's a sort of barely visible line connecting the view to the controller. It is communicating indirectly using things like target action and delegation. Similarly, the model object can communicate with interested observers using key value observing and notifications. So this is a slightly less bite-sized chunk of knowledge, but it maybe more accurately reflects what the relationships are in model view controller. Actually, yeah, maybe in the view to model one, I'll make that I'll make it like a halfway between pure white and unreadable, so that you understand it's a little bit more of a gray area. So this is pretty much all we're going to cover in terms of model view controller today. If there's any last remaining philosophical questions or what should I do with my life kind of things going on here, I can answer them now, or we can just keep going. All right. Now we're going to get into some code, get into some specifics of UIKit, and talk about view controllers. And before we really get into, well, okay, I lied. We're not going to write code just yet. I want to present a couple of problems, first of all, and then we're going to look at how view controllers attempt to solve these problems. The first problem is that controllers, they manage views, they manage data, they manage application logic, and apps are made up of many of these controllers, especially when you've got an app that's got 7 different types of screens. It would be nice to have a sort of common language of talking about these chunks of your app, these slices of your app. Chunks, slices, describe it however you like. And kind of a standard starting point for these types of pieces of code. So whenever you're writing a view class in an application, you'll most often subclass UI view. That's the obvious starting point, where you get some behavior for free, you get draw rect, you get the frame method, set frame, all that sort of stuff. So we want an equivalent sort of starting point for controllers, especially the types of controllers that manage a screen full of content. The other problem, which we'd like to solve, is that there are some really common application flows. The ones we talked about before, navigation-based app, tab bar-based apps, combinations of the two. There are a million apps like this out there. Actually, I think there probably are literally, well, wait, how many apps are in the App Store? 10,000. There are 10,000 apps like this, maybe 8,000. So we really want to avoid reinventing the wheel here. We want to be able to plug individual screens together to build an app without kind of figuring out how to do that from scratch every time. And actually, in the early days of iPhone app development, internally, when we were working on the system apps, that was how it was. UI navigation bar existed. But if you wanted to write an application where the user interacted with that navigation bar, and we also slid between different screens, you sort of had to link those things together yourself and write a lot of code to keep them all synced up. And after doing it over and over and over, and we're like, okay, we got to write mail. Mail's a navigation-based app, and we're going to write address book, and address book is a navigation-based app. At some point, especially, one of our sort of philosophies at Apple is that if you've done the same thing over and over a couple of times, do what you can to make it reusable so that you don't have to keep doing it. And then so when down the road you write the YouTube app or the whatever, the App Store, that sort of stuff, you can kind of have a head start and avoid doing these things from scratch. So these are the two types of problems that we attempted to solve. And the result is a class called UI View Controller. Think of it as the sort of basic building block of your application logic. It manages a screen full of content, the views, the data, any sort of behavior. And typically, you will create a subclass of UI View Controller to manage a view that you're creating, and you'll add in your, like we said, the brains of your application to it. So, here's the view controller. It's got views, it's got data, it's got logic. You can think of it as the glue that holds all these things together. Some people talk about glue code in a sort of disparaging way. I think glue code is bad if you have to write a lot of it. If you can write a sort of limited, focused amount of glue code tying things together, then I think it's all right. You think of it as the rug that ties the room together. Whatever metaphor you prefer, latch onto it, think about it in that way. Let's talk about your view controllers and our view controllers. And here I'm using the royal we to talk about Apple and the UIKit team and all that sort of stuff. So you're typically going to create your own UI view controller subclasses for each screen full of content in your app. And then you will often plug them together using the existing composite view controllers, like the ones that we have for creating navigation-based and tab bar-based apps. So kind of looking here, if you're making an app with navigation that has a hierarchy of content, the view controllers on the right are probably going to be ones that you've written yourself. And what they're displaying, God only knows, but you've written a bunch of code to do it. And then because you don't want to reinvent the wheel with the navigation-based application flow, you can use a navigation controller out of the box without customizing it too much, and plug these things together. The other example, obviously, is the tab bar controller. So rather than having a sort of a hierarchy of view controllers, it's got a list of parallel, mostly unrelated view controllers. So these are the two common ways to take your view controllers, plug them together to build an entire application. Does that make sense? We're not going to talk too much about navigation and tab bar controllers today. Actually, we're not going to talk about them at all really after this. But on Thursday, we're going to go into more depth and show you how to build a navigation-based app, what some of the things are that you can customize. And this is actually going to be part of your President's 1 assignment, is going to be to create a couple of UI view controller subclasses that each manage a screen full of content, and then plug them together using a navigation controller. So keep that goal in mind as we're talking about this. All right, let's look at some code finally. You've been waiting long enough. As usual, we pound import uikit/uikit.h. We're going to subclass UI view controller, as I mentioned before. And just in this trivial little example bit of code up here, I wanted to illustrate, it's got views, it's got data. So maybe this view controller has some data, some array of who knows what, strings, numbers, polygons. And in this case, it's got a label that it's managing on the screen. Maybe it's customizing what that label displays. This view controller may expose some of its contents to clients. So in this case, this is kind of interesting. NS mutable array is a subclass of NS array. So maybe to its clients, it advertises this array as a straight up NS array that cannot be modified, even though under the hood it's actually an NS mutable array. This isn't really important to this demo, but I figured I'd just throw it in there to confuse you. And maybe it responds to some actions. So it's got this method, do some action. That void there could probably be IB action, right? To indicate that it's a method that interface builder should look for when you're hooking up button actions. So that's sort of high level what the declaration of your view controller subclass looks like. Let's talk about the view in UI view controller. Obviously, this is a pretty key part of view controllers. So a view controller, UI view controller, the superclass, the base class, has a view property. It's retained by the view controller. It's just called view. So if you wanted to change the view associated with the view controller, you would say viewController.view equals whatever. Or if you wanted to get it, you could say, my variable equals viewController.view. We're all good with dot syntax and setters and getters. That's all old news by this point. One thing to think about is that the view is going to load lazily. So typically, you might instantiate a view controller, and it may not actually have instantiated all of its views yet. Maybe it's got a serious, complex hierarchy of views. It's got that single view outlet, and maybe that view contains a bajillion, that's the second time today I've used that word. It's got a lot of subviews, and maybe those are expensive to create. So the loading happens lazily, whether it's in code or from a nib. It can also be purged if you get into a low memory situation. So view controllers are responsible for dumping memory if there's a low memory situation on the phone. One other thing to think about is sizing and positioning the view. Typically, you're not going to size and position the view that's managed by a view controller until you're actually ready to use it on the screen. So rather than laying things out in an interface builder and saying, okay, well, this view is definitely going to be 460 pixels tall, and it's always going to be that way. Try to be flexible. Don't make too many assumptions, because it may be used within a navigation bar. If it gets pushed onto a navigation stack, and we're going to talk about that more on Monday or Wednesday. It's going to be shrunken by 44 pixels at the top of the screen. Similarly, if there's a tab bar down at the bottom of the screen, that might trim off some of the view as well. So you want to kind of be a little bit agnostic as to the actual sizing of the view. And we're going to talk a little bit more later about some ways that you can make sure that you adapt. So when are you going to call load view? There's this method called load view, which is defined on UI view controller. As usual, this is one of those setups in the lecture where I'm going to say, never, don't do it. As you're seeing in a lot of places, Cocoa tends to embrace a philosophy of laziness. UI view, rather than calling drawRect, you call setNeedsDisplay. And some other bit of code in the framework will decide, okay, this is a good time to draw. Now I'm going to call your drawRect method. Similarly with deallocating memory, you don't ever call dealloc directly. You call release, and the memory management architecture figures out when the right time is to actually dispose of your object. So why do we do this? Really, it allows you to defer or coalesce or avoid doing work. So this can be very helpful as far as performance goes, especially something like application launch. One surefire way to make your application take 10 seconds to launch is to load up all of the views for every possible screen in your application and load up all the data and load up this 20 megabyte SQLite database and get everything all ready to go. I mean, it'll be fast when it's time to display it, but your user might not even navigate to that 8 deep screen someplace in your app. So it's kind of a waste if it's not actually ever going to be used, and certainly the time locality is not very good there. So one of the best ways we've found to help out both application launch time and any other sort of situations where you're initializing, bringing something new into your app, is to do as little work as possible. When we talk more about performance later this quarter, this will be one of the sort of philosophies of, one way to make your app run faster is to go and hand tune and try to make your code faster and go line by line and say, well, we could call this method instead of this method, and that'll be 10% faster. Well, if you could just chop out that line altogether, that's an even bigger win, right? So think lazy. Laziness can be good. Let's talk now about, so we've talked about how lazy view loading happens and how each view controller has a view. Let's look at the two ways that you can hook up a view controller with a view to display. So the first way to do it is in code. So if you're an old school computer hacker like me and Paul, you will override load view in your UI view controller subclass. Again, don't call load view directly. It'll get called when somebody else asks the view controller for the view to display on screen. You create some views. Maybe you've defined this custom class, my view. We call it initWithFrame, just as all most views do. Create your views. We got our memory management going on here, and then you assign it to the view property of the view controller. So again, this is within a view controller subclass. We're going to say self.view equals my view, and at that point, the view controller owns it. It's OK to release here because the ownership has been passed on. So there may be times when you do this. More frequently, I'm guessing you're going to use interface builder to lay out the view and hook it up to a view controller. So and then you're going to instantiate the view controller using the init method. Let's look at the interface builder route. That's actually what you're going to be doing in Presence 1. So if you're using interface builder, you're going to crack OpenIB, and you're going to open a new document, and you're going to say view, and it's going to bring this blank view onto the screen. What are you going to do? First thing is, remember you've probably seen this files owner object in here. This is the object. It's a proxy. It's sort of a promise for a future object that loads the nib. So what you're going to do is select the files owner. And remember the whole custom class setting thing where there's that view in Interface Builder where you can pick a custom class. We're going to do a demo and show this to you in a bit. But the keys to remember here are that you're going to set the custom class of the files owner to your view controller subclass. So if you've got a polygon view controller that knows all about displaying this screen with a polygon on it, you're going to click on the files owner in your polygon view controller nib and set the files owner to that class. The next thing you're going to do is hook up the view outlet. Once you've defined the custom class here, you're going to be able to do the control drag thing in Interface Builder and basically say to the files owner, to the view controller, hey, here's your view. That's equivalent basically to saying view controller dot view equals something, equals some view. In this case, you're then going to, when it's time to create the view controller, you're going to call init with nib name and bundle. Obviously, the nib name is a string. It's the name of the nib that it's going to be owning. The bundle, you can actually just pass nil here most of the time. There are very rare cases where you'll need to specify a bundle. But yeah, that's sort of the high-level view of having a view laid out in Interface Builder managed by a view controller. Yeah, question? It's a good question. So the question was, you need to set the files owner per view controller, right? So if you've got multiple screens, you're going to be doing this multiple times. Now, it's important to remember here, every nib has a single files owner. This actually goes back to the lazy loading thing, but rather than trying to fit all of your application into a single nib, what we really recommend is to have a nib for each screen. So each of those nibs will have different files owner. So you maybe got 3 different view controller classes. In the presence example, maybe the top level one is the people list view controller, and it's got a nib that knows that has the list. And then you've got a person detail, and that's got its own. It's got its own view controller subclass. It's got its own nib. That's all set up and ready to go. And maybe you've got some third level. We don't require you to create a third level in Presence 1, but you kind of go on and on like that, breaking these things up into manageable chunks. The advantage there is that you avoid, if you have your entire application in a single nib, you've got to load in that entire nib. There's no sort of partial nib faulting. So by breaking things up into multiple nibs, you can have some better performance. Does that make sense?
So you're also aiming for one view controller per nib?
Yeah. Typically there's a one-to-one relationship between view controllers and nibs. So obviously that view controller may be then instantiated multiple times, but it's going to be pulling its view from the same nib file on disk. Okay. So let's see a little quick demo of this. Just to, it's been kind of abstract up until this point. Wow, this laptop is really hot. If I scream out in pain. Okay, so what I'm going to do is go to New Project in Xcode. And before I do that, I'm going to turn on accessibility so I can zoom in on the screen. Here we go. So hopefully this is a little bit better for those of you watching at home. So we've been using the window-based application template previously. In today's demo, we're going to use a view-based application. So we're going to select view-based application under iPhone apps and hit choose. And we're going to call it view. Now, I hope that doesn't end up with, view controller. That wasn't so smart. So what's going on here is we've got sorry, I just can't live with that. Let's do it again. View-based application, how about test? I love test. good old test. So that gives us an application delegate and a view controller subclass as a starting point. So in this view controller subclass, subclass is UI view controller. Right now it doesn't really have anything in it. If I go into resources here, you'll see I've got two nibs. The first one is the main window, and the second one is the test view controller. So if I crack open the main window nib and open up the window, you'll see there's nothing in it, and that's actually okay. What's going to happen in our application delegate, if I make this a little bit bigger, is that we add the view controller's view to our window at launch time, and then we're going to make the window visible. So this is going to basically take our view controller, ask it for its view. That'll load the view from some other nib. In this case, lazy loading didn't really get us much because we did both at application launch. But if we've got 5 or 10 view controllers, then this will save us quite a bit of time. If I look at the test view controller interface builder file, let me just do that again. So here we go. We've got test view controller.zib. If I click on Files Owner and then go to the 4th tab in the inspector, you'll notice IB has already set up for us the custom class right here. That was kind of handy. So if I needed to do it myself, I would click right here, type in the name of the view controller, and go like that. Then we want to make sure that the connection is set up between the view controller and its view. And as you can see here, it is. If I wanted to reset it just for illustration purposes, I could drag from here over to the view. Hey, it likes it. And then we've got the view outlet all hooked up. So those are the 2 steps that you need to follow to make sure that the view controller and the view are happily wedded to one another. And now if I want, inside this view, if I close this window here, I'm just going to drag out a text field from the library. So here I am in the library. I drag a text field out and position it right about there. OK. Now, if I build and run from Xcode in my huge iPhone simulator, you'll notice that the view controller's view got added to the window. Its view contains that text field there. And we can do whatever we want, type some stuff in that text field. So these are the bare basics. This is going to be posted on the course website, so you can poke through here and investigate a little further. But I wanted to talk about what you do next, how you start to hook up some behavior into your view controller. So the view controller lifecycle. Is this going to work? Just one moment. All right. There we go. So in this case, what's actually happening under the hood is that init with nibname and bundle might be the method that you call to instantiate your view controller. And this is where you might do some initial setup. Maybe you've got some data that you want to load. Actually, well, in this case, it's pretty inexpensive to create an array. You might want to do this a little bit later if there were a lot of data that you wanted to load. And you can do things like setting the title of the view controller. Every view controller has a title that can be displayed in a navigation bar or a tab bar. Things like that, sort of basic setup. The next interesting event in the life of a view controller is the viewDidLoad method. And at this point, you can be certain that your view controller's view has been created and set to the view property, either via interface builder or the load view method. So at this point, you can do things like, if we've got some weird view property, we can set it on the view because the view is ready to go. We're not going to incur any hit by loading the view. The next interesting point in the view controller's life cycle is when it's about to appear on the screen. And this is a method that you're going to be probably overriding quite a bit in the Twitter app. You'll implement it, you'll override it. You always want to call super, view will appear, because the super class may need to do some work here. And at this point, your view is about to show on the screen. So this is a great place to maybe begin loading some data from the internet. You're pulling something from the cloud and getting it ready to display in your application. So this is a good place to kick that off. And maybe we want to start showing a little spinner because we're downloading that data remotely. Anything that you sort of want to be ready in place on screen when the view gets displayed, you'll want to do in here. Counterpart method is going to be view will disappear. So this is, on the flip side, when your view is getting ready to leave the screen, you can do things like saving state out to disk. Maybe your user has added some new data, they've modified some data. Maybe they have a list of 10,000 songs in their iPod app, and you don't want them to have to scroll back down to the exact spot that they were at. So maybe you want to remember their scroll position and restore it at some later point. So these are going to be the most common places where you write some bits of code to get your view controller good to go in terms of display on the screen. So let's, in terms of the specifics of loading and saving data, there are a lot of ways to do it. NS user defaults is one example. There are a lot of other options. There's property lists. There's SQLite, which is built in on the phone, better for large sets of data. And there's also web services. You can call out to some server and get some data back. We're going to be talking about this in pretty great depth in lecture 9, which is going to be next Wednesday. For now, for this little demo here, we're just going to use NS user defaults. So let's do a quick demo here. What we're going to do, you notice we added that text field to our view controller's view. We're going to persist the contents of this text field across application launches. So if I pop back here into Xcode, let's go to our view controller class, and I'm going to add an IB outlet, a UI text field, and I'm just going to call it text field, just like so. And then if I flip back into Interface Builder, you'll notice I can control drag. I'll zoom in a little bit. I can control drag from the file zoner to the text field, and it'll say, hey, do you want to hook this up to the text field outlet? And I say, sure do. And you know what? Actually, let's add a button into the mix and have the button invoke a method on the view controller. So we'll call it button pressed. And that takes a sender, as most action methods do. And I'm going to drag a button out here. So much for my absolute positioning. There we go. We'll call it done. And I'm going to control drag from the button itself back over to the file's owner, which again is a sort of stand-in for the view controller. And I'm going to have that invoke the button pressed method. So now if I click on this button and I go to the connections inspector in IB, like that 5-finger zoom right there, you'll notice that touch up inside is hooked up to button pressed. So now what I want to do, since we can ignore most of the, there's some code that you get for free in a UI view controller subclass if you create it from IB. We're not going to worry too much about that right now. What I really want to do is implement that button pressed method. So we type button pressed, ID sender. Now, in this little bit of code here, actually the sender will be the UI text field. So if I wanted to refer to it in that way, I could just say sender and I could call some methods on it. Because I've got an outlet to the text field already, just for the sake of clarity, what I'm going to do is just say text field and editing, and I'm going to say yes to force it just in case it needs to be forced for some reason. So from here, if I build and run Apple R from Xcode, you'll notice I can type some text here, and I can hit done, and it'll go away. Tapping that done button invoked the button pressed method on the view controller. Again, the view controller is the brain behind this screen, and it says to the text field, hey, you're done, stop editing, and that actually causes the keyboard to go away automatically. From here, what we're going to want to do is load and save the contents of that text field when we appear and when we disappear. So what we'll do, let me just make sure, is that implemented in here? No, it's not. Good. Templates are great. They give you hints as to where you might want to put some code. But be careful, sometimes there may be a method already implemented and you go and start typing and bad things happen. So view will appear, takes an optional, or it takes a parameter which is whether or not it's animating or not. Because you may want to do things differently depending on animation. In here, what I'm going to do is I'm going to get a string out of NSUserDefaults. So I would say NSUserDefaults, shared, standard user defaults. And then I'm going to say string for key. And the key is going to be, let's just call it something simple, my string. We've got to make sure to use the same string wherever we refer to this. Here we go. So I'm going to get this string out of user defaults, and I'm then going to say text field, text field dot value dot text, equals string. Do I need to release anything here? Nope. The answer is no. I didn't call alloc. I didn't call copy. This user defaults will return an auto-released string to me. If I wanted to retain it, I could call retain on it. The fact that I'm immediately assigning it to the text field will actually be responsible for retaining any string that it displays. So I don't need to worry about memory management here. The counterpart bit of code that I'm going to write is view will disappear. So I'm going to implement this method. And now I'm actually going to get the string back from the text field. And I'm going to write that to NSUserDefaults. So I'm going to say NSUserDefaults, standard user defaults. This is a class method on NSUserDefaults where I'm going to get this object. It's sort of like a dictionary. And I'm going to say set string, set object. So the object will be the string. And for the key is going to be my string. The reason there's a convenience method for getting the string, but there's not one for setting the string, is that if I just called object for key up here on my string, I might need to then cast it into an NS string if I was assigning it to an NS string variable. Down here, though, given that object, let's see, what does it take? It takes an ID. So I can basically pass any sort of object in here that knows how to persist itself. Strings, numbers, arrays, dictionaries, all that good stuff. So I can just pass it in there. It doesn't matter what the object is. So I've written these two little bits of code, and if all goes according to my plan, this will persist itself. So let's try it out. Hello, mom. We're done, just to make sure. We'll quit. We'll launch it back up. Hey, it worked. Okay, that worked. I can quit out of here, launch it back up, and the string is there. So view will appear, view will disappear are great places to sort of put loading and saving type code. Let's pop back to the slides, and we'll see, is this guy working? Yeah, it is, cool. So UI View Controller provides some hooks for you to write, places for you to write code. View will appear, view did appear, view will disappear, view did disappear. There are a bunch of permutations. There are some other interesting things you can do, like automatically responding to interface rotation, things like low memory warnings. There are actually a bunch of other things that you can do where you get hooks, you get methods that you can override in UI View Controller. Let's talk specifically about interface rotation, because this makes kind of a cool demo. We don't really have to write much code. There's this method that UI View Controller defines. The method is should auto-rotate to interface orientation. Again, in Objective-C, we're not terribly brief in some of our method names. So what we're going to do here, basically, the point of this method is to return yes for all the interface orientations that you support. So this is like do I support this orientation, period, or no? So in this case, we're just returning, interface orientation double equals UI interface orientation portrait. So this particular view controller, whatever view controller it is, only supports the standard portrait orientation. Now we might want to allow landscape left, landscape right, like Safari or the Photos app. So what we would do in that case is if we wanted to support everything except for the upside down orientation, which can't say I've ever understood the upside down orientation, but it's there just in case you need it. In this case, we'll return interface orientation is not equal to UI interface orientation portrait upside down. So this one supports everything except for the upside down orientation. So this is kind of the model. Typically, your should auto rotate to interface orientation method will be pretty simple. You're not going to have a bunch of complicated logic to, check a bunch of state and then decide, yes, I support landscape left or landscape right. It'll be pretty simple. So let's do a quick little demo of this. I'm going to write a couple lines of code and enable interface rotation in this little app of ours. So actually, I think, here we go. So the template gave us a default implementation of this method. So return interface orientation double equals UI interface orientation portrait. So let's change it to the other implementation that we saw. We're just going to say we want anything except for UI interface orientation portrait upside down. So if I do that, and I cross my fingers and hit Apple R and run this thing, in the simulator, you can actually simulate interface auto rotation. There's this hardware menu, and you can do rotate left, rotate right. So I'm going to hit Apple left, and we'll see what happens. Hey, it rotated. We get this sweet, animated animation here, and yeah, it just kind of works. If you want to have more complicated, animations along with the rotation, or if you've got views that need to change their size, that's when it gets a little bit more dicey. I'm going to give you a little pointer in that direction, but it's not something that we're going to look at too hard right now. And the easiest way to do that is to use something called view auto-resizing. And what you can basically do is say, for a given view, this could be the top level view of your view controller. It could be something inside it. You can set the auto-resizing mask, and it's basically just a bitwise OR of different values. So if you wanted a view to resize in every direction as its parent view changed size, you want it also to grow or shrink to fit those dimensions. You would say UI view auto-resizing flexible width, and then OR that with flexible height. And that'll get you a view that is just sort of super malleable. It can be stretched out. You can do this in Interface Builder by going to the third tab in the inspector. And as you can see down here in the lower left, we've got these arrows in the middle of the view. And what those indicate is that we've got flexible height and flexible width. And we've also got it pinned to the top and bottom and left and right edges of its super view. And that's the default. If I wanted to instead have a view which didn't grow and shrink vertically, but just kind of stuck to the bottom of the screen for something like a toolbar, this is how it would look like in Interface Builder, and as well, this is what the code would look like. You can do it one way or the other. So in code, I would say UI view auto resizing, flexible width, just like we had before, and I would also say flexible top margin. And what that is basically doing is removing this little the little pin, what's it called, the strut at the top of the view. So and then Interface Builder actually has a cute little animation where it'll show you what this view would do as its super view changed size. So that's kind of handy right there. We're not going to go too much in depth here, but this is something you can fool around with in your project. With all that covered, it was kind of a lot. I just want to do a quick little intro and demo of the Presence application. So as we've mentioned before, we're going to build an iPhone application for viewing online status updates. This is the answer to the question of what are you doing right now, or Facebook, what's their new little prompt? It's like, what's going on, or how are you feeling, or something like that. So our assignments will be using the Twitter API. It's very simple. It's easy to just sort of dive in and start getting some real data. And obviously, this could extend to Facebook updates, IM status, RSS feeds, You could build some sort of Uber app that combines all of these things together and lets you know everything that everyone you know is doing on the internet anytime it happens. Kind of that's everyone's dream, right? So there are going to be 4 parts of this app. In this first week, we're just going to be dipping our toes into using view controllers and using navigation, which again we'll be talking about on Wednesday. So part 1, we're just going to build a simple app that displays some static data. You can have it display whatever you want, and it has some navigation. Next week, we're going to talk about managing and displaying real data. So we're going to switch over to using table views, which can display a tremendous amount of data to the user. And we're actually going to be pulling down real data from the web. Part 3, we're going to talk about threading, performance, avoiding just having your application lock up on the user. We're also going to talk about text input, modal content. I'll explain what that is later. And part 4, we're going to do some search. We're going to add a bunch of different modes to the application. So we're going to throw a tab bar controller into the mix. We're going to do some address book integration. And you can basically extend it however you like at that point. Here is what part 1 is going to look like. Ignore that date up at the top. That was cute. Wednesday, it's due several months ago. So the goals are to create your own view controller subclasses and present a hierarchy using UI navigation controller. And that'll be next lecture. So here we've got Troy. I don't know where I got that photo from, but I like it. So let's do a quick little demo of what this app is going to look like, and then you are going to be free to go. Oh, I've still got this one running. Cannot launch in simulator while already in use. And just for kicks, let's switch over to 2.2. I guess we were on 2.1 last quarter. So here's what the app is going to look like, thoughtfully updated for this quarter. Thank you, Facebook, for these lovely photos. So here we've got Alan. He is, he's in Boston today, so that's his status. Paul. He's doing his little risky business karaoke. And Troy, I think his status has been updated. Yeah, grading assignments in the front row now. So right here, this is, as you might have guessed, not real data coming from out there on the cloud. This is just some static stuff that I've typed in. I've got some images that I've dragged into the project. There's a pretty thorough walkthrough in assignment 1, which will be posted on the website later tonight. But we're just going to be dipping our toes in, getting a feel for putting together a real application with multiple screens. With that, unless I've forgotten something, no, we're cool. Any questions? If not, see you on Wednesday.
For more, please visit us at stanford.edu.